In this section, we're going to be adding and subtracting numbers with different bases. But before we do that, let's consider base 10. That's the system we use in our daily lives. But what are the symbols of base 10? Base 10 has the symbols 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's it. So these are all the symbols for base 10. You have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, and that's it. When we get to a number larger than 9, we start repeating the characters. So instead of another symbol, we use a 1 and a 0. What does that represent? It represents 110 and 0 ones. If I have another number, let's say 57, this represents 5 tens and 7 ones. So that's how our system works. We have to go to the next position to increase our number, but we use the same characters. We use 0 through 9, and that's it for base 10. Now let's consider adding 1, 2, 3 plus 5, 6, 7 in base 10. What I would do is I would stack them 1, 2, 3 on the top, 5, 6, 7 on the bottom, and we're going to add. Now when we add, we look at the right column first. What's 3 plus 7? Well, that's 10. But you don't put a 10 down here, there's not enough space. You first put the 0 and you carry the 1 over. So that means we put a 0, there are 0 ones and 1 10 carried over. Then we add 1 plus 2 plus 6 gives us 9. And then we add 1 plus 5 gives us 6. So 1, 2, 3 plus 5, 6, 7 is just 690, which means we have 6 hundreds, 9 tens, and 0 ones. That's what this number represents. Let's look at question number 2. We have 1,808 plus 345. We're going to add this again. 8 plus 5 gives us 13. But we don't put 13 down here. We put a 3 and we carry the additional 10 over. So we're carrying that 1 over, but that represents a 10. 1 plus 4 gives me 5. 8 plus 3 gives me 11. We don't put 11 here, we put a 1. Carry that additional 10 over, and then we add 1 plus 1 gives us 2. So you're all familiar with adding in base 10. But now let's try something else. Let's try base 5. Before we do base 5, what's the symbols for base 5? Well, it's 0, 1, 2, 3, 4. That's all of the symbols for base 5. You cannot write the number 5 in base 5. You can only write 0, 1, 2, 3, 4. So let's try question 3a. This is base 5. So we have a little note here to tell the reader this is base 5. So we'll put 43 base 5 on top plus 24 base 5 on the bottom. Now let's begin adding. What is 3 plus 4 base 5? Now some of you might think 3 plus 4 is equal to 7. Well, that's in base 10. We're not in base 10. So 3 plus 4 does not equal 7. 3 plus 4 in base 5 is equal to 1/5 plus a remainder of 2. So this 1 represents 1/5, and this 2 represents 2 1s. Remember, we're talking about base 5, so the powers of 5 are 5 to the 0, that's equal to 1. 5 to the 1 equals 5. 5 squared equals 25. So the first one represents the 1s, the next one represents the 5s, and then we have the 25s, and so on. Just like in base 10, you have the 1s, the 10s, the 100s. They're all powers of 10. Here we have all powers of 5. So what is 3 plus 4? Well, that's going to give me 2, and I have to carry that 1. Now this 1 represents a 5, so I'm actually carrying the 5 over and having a remainder of 2. Remember, 3 plus 4 is 1, 2 base 5, because this is a 5 plus 2, which equals 7 in base 10. So 3 plus 4 is 1/5 with a remainder of 2. Now we'll add 1 plus 4 plus 2 is going to give me 7. Again, 7 is not possible in base 5. So we have to write 7 in terms of powers of 5. So that's 1/5 with a remainder of 2. So this gives us 2 here, and I have to carry the additional 1 to here. So we have our solution is 43 base 5 plus 24 base 5 is 122 base 5. Let's look at question B. We'll add 313 base 5 with 233 base 5. Now remember, we're working in base 5, so you can only have a 0, 1, 2, 3, or 4 as a character in base 5. 3 plus 3 is 6, but 6 does not exist. We can't do that. You have to rewrite this in base 5. 6 divided by 5 equals 1 remainder 1. So we put a 1 down here, and we'll carry the 1 over. Now 1 plus 1 plus 3 is 5, but 5 does not exist base 5. So you have to convert this by doing 5 divided by 5. That's 1 remainder 0. So we have 0 here, and we'll carry the 1. 1 plus 3 plus 2 is 6. 6 does not exist in base 5. So we'll convert that. Again, that was 1 remainder 1 or 1, 1. So here is our solution for part B. 1, 1, 0, 1, base 5. Let's look at part C now. Let's stack it all up. 3, 4, 2, 0, 1, 2, 0, and 22. Recall all of this is base 5, so we can only have 0, 1, 2, 3, 4. There are only 5 symbols in base 5. 4 plus 0 plus 0 plus 2 is 6. 6 does not exist, so we'll divide it by 5. That's 1 remainder 1. I have a 1 here. Then we'll have to carry that additional 1. 1 plus 2 plus 2 plus 2, that is 7. 7 does not exist, so let's divide that by 5. I get 1 remainder 2. So we have a 2 down here, and then we'll carry that additional 1. 1 plus 3 plus 1 is 5. 5 does not exist, so let's convert that to 1 remainder 0. So we have a 0, and we'll carry that 1 over. So our solution is 1, 0, 2, 1, base 5. Don't forget the base 5. Let's add 1000 base 5 plus 100 base 5 and 10 base 5 together. Well, 0 plus 0 plus 0, that's 0. We have 0, 0, 1 together, that's just 1. 0 plus 1, that gives me 1. And 1 plus 0, 0, that's still going to give us 1. So this one wasn't too bad. Part D, 1000 base 5 plus 100 base 5 plus 10 base 5 is 1110 base 5. In question number 4, we're going to work with different bases now. We're looking at base 3. So I always look at the characters for base 3. I have a 0, 1, 2, and that's it. There's only 3 symbols for base 3. Now let's do some addition. 1 plus 2, well, that's equal to 3. 3 does not exist in base 3. So let's divide it by 3. I get 1, remainder 0. So that means I have 0 ones, and I'll carry 1 3 over. 1 plus 0 gives me 1. And then 2 plus 1, that gives me 3. But 3 doesn't exist, so we'll put a 0 and carry 1 3 over. So 201 base 3 plus 102 base 3 is 1010 base 3. For part B, we're looking at base 4. Let's look at the symbols for base 4. 0, 1, 2, 3, and that's it. There is no other symbols for base 4. We'll add 2 plus 3 together. 5 does not exist in base 4. So we'll take 5, divide it by 4, I get 1, remainder 1. So what that means is, I have 1 here, and I'll carry that 4 over. And now we'll add 1 plus 1, that's 2. 2 exists in base 4. 3 plus 2, well that's 5 again, I know that's going to be a 1. I have to carry that 1 over again. And then 1 plus 2, that's 3. So we have 3, 1, 2, 1, base 4. Part C, we're looking at base 6. Let's put the symbols for base 6. 0, 1, 2, 3, 4, 5. There is 6 symbols for base 6. Let's add 5 base 6 plus 4 base 6. Well, 9 does not exist. So let's convert 9 to base 6. Divide that by 6, I get 1 with a remainder of 3. That means we have 3 ones, and then I'll carry 1 6 over. 1 plus 5 plus 3 is 9 again, so we'll have a remainder of 3, carry that 1 over. 1 plus 2 plus 1, that gives me 4. So 255 base 6 plus 134 base 6 is 433 base 6. For part D, we're adding base 2 together. So let's look at the symbols for base 2. I can have a 0, I can have a 1, and that's it. The only 2 symbols for base 2. Now 1 plus 1 is not equal to 2 in base 2. So we'll convert 2 to base 2. We'll divide it by 2. I get 1, remainder 0. So 1 plus 1 is actually 0 here. Carry that 1. 1 plus 1 again, we know it's 0. Carry that 1. 1 plus 1 again is 0. We'll carry that 1. 1 plus 1 again is 0. We'll carry that 1. Now 1 plus 1 plus 1 is 3. 3 does not exist base 2, So we'll divide it by 2. I get 1, remainder 1. That means I have 1 down here. We'll carry that additional 1 over. And this is, again, base 2. So that's our solution for part D. In question 5, please try these on your own. Pause the video, see if you can do it. I know it's a little bit different, but remember the characters for each of the bases, and then you'll be okay. Just divide by that base to figure out what the actual number is in that base system. Hopefully you have done the problems. Now let's go over the answer. For part A, this is base 6, so the symbols are 0, 1, 2, 3, 4, 5 for base 6. For part A, we are adding base 6, so let's put 234 base 6 on top and 452 base 6 on the bottom. We'll add 4 plus 2, that gives us 6, but 6 does not exist, base 6. So divided by 6, you get 1, remainder 0. That means we have 0, and we'll carry that 6 over as a 1. 1 plus 3 plus 5 is 9. That means 9 divided by 6 is equal to 1, remainder 3. I have a 3 down here, and I'll carry that additional 6 over. Remember, 9 does not exist base 6, so we'll convert it to base 6 as 1, remainder 3, or 1, 3. We have 1 plus 2 plus 4, that's 7. 7 does not exist base 6, so we'll divide it by 6. We get 1, remainder 1. So this is equivalent to 1 here. Carry that 1 over, you get a 1 here. And so this is our solution, 1, 1, 3, 0, base 6. For part B, I only have 2 symbols, 0 and a 1. So let's stack these numbers up. 1, 0, 0, 1, base 2. And 1, 0, 1, 1, base 2. And now let's add. 1 plus 1 is 2, but 2 does not exist, base 2. 2 divided by 2 gives me 1, remainder 0. So I have 0 ones, and I'll carry that 2 over as a 1. 1 plus 0 plus 1 is again 2, but 2 does not exist, so we'll use 0, carry that additional 2 over as a 1. 1 plus 0 is 0, that's 1. 1 plus 1, that's again 0, carry the 1 over. For part C, the only symbols that we have for base 4 is 0, 1, 2, and a 3. So let's stack it up. We have 2, 3, 1, base 4, added with 2, 1, 3, base 4. 1 plus 3 is 4, but 4 doesn't exist. 4 does not exist, so we'll have to convert it to base 4. 4 divided by 4 is 1 with a remainder of 0. So this should be a 0, and we're carrying that 4 over as a 1. 1 plus 3 plus 1, that's 5, but 5 doesn't exist, so we'll divide that by 4. I get 1, remainder 1. So that means we have a 1 here, and we'll carry that 4 as a 1. 1 plus 2 is again 5, so I know that's 1, when we'll have to carry that 1 over again. Don't forget our base symbol here, so we have 1, 1, 1, 0, base 4. Now let's review subtracting with base 10. This is the system you all know how to do. So we'll do 1, 2, 4, 5, subtracting 128 on the bottom. Now when you do this, We cannot subtract an 8 from a 5. We have to borrow. So you usually cross out the 4 and reduce it by 1, which gives you a 3. Then what do? Well, you add 10 back to the 5. And you cross it out and you replace it with a 15. So this 5 becomes a 15 because we're in base 10, we borrow a 10. So 15 minus 8, we know that's going to give us a 7. 3 minus 2, that's a 1. 2 minus 1, that's a 1. 1 minus nothing is 1. So that's our solution in base 10. We borrow a 10. Let's see that again. We have 2, 0, 1, and we're subtracting a 5. Now, 1, I cannot take away 5 from it, so we'll borrow from the 0. The 0 has nothing to borrow, so we'll borrow from the 2. This reduces to a 1, and this 0 becomes a 10. Then we can borrow from the 10. This becomes a 9, and we'll carry that additional 10 over, and this 1 actually becomes an 11 because we're adding 10 to it. So now we have 11 minus 5, which is 6. 9 minus 0 is 9, and 1 minus nothing gives us 1. So we have 196 from this one. Again, we're borrowing 10. If the next placeholder doesn't have enough, we'll go to the next placeholder to get another 10. So now we could work with different bases. Let's subtract 1142 base 5 minus 213 base 5. Again, we'll still stack it the same, no difference. This is base 5. Now I cannot take away 3 from the 2. 2 is too small, so we'll have to borrow. We'll have to borrow from the 4. So we'll cross out the 4 and reduce it by 1. That gives us a 3. Now, when we add it to the 2, we do not add 1 to it. We don't borrow a 10. This is base 5. So we're actually adding a 5 to this. So we borrow from that 4. We're borrowing a 5. So this 2 actually becomes 2 plus 5, or 7. Now we can subtract. Gives me 4. I can now subtract 3 minus 1, which is 2. 1 minus 2, that's not possible. I gotta borrow. So let's borrow from this 1, and that becomes a 0. But I'm not borrowing 10, I'm borrowing 5. This is base 5. So we'll add a 5 to this 1. So this is actually 6. Let's subtract now. 6 minus 2 gives me 4. So our solution is 4, 2, 4, base 5. When you borrow, you're borrowing a 5, not a 10. Let's try that again. We have 2, 3, 3, 1, base 5, subtracted by 1, 2, 4, base 5. I know that I cannot take away 4 from the 1, so we'll have to borrow from the 3. The 3 reduces to a 2. Now I add a 5 to the 1. That makes this 1 a 6. 6 minus 4 gives me 2. 2 minus 2 gives me 0. 3 minus 1 gives me 2. And the 2 just comes down. So that's our solution. 2, 2, 0, 2, base 5. For part C, we'll do 4, 1, 1, 2, base 5, and I'm going to subtract 1, 4, 3, base 5. We cannot take away 3 from 2. We cannot take away 3 from 2, so we'll have to borrow from the 1. That becomes a 0. Since this is base 5, I'm going to add 5 to the 2, which makes it a 7. Now we can subtract. 7 minus 3 gives me 4. Now 4 cannot be taken away from 0, so we'll have to borrow from the 1. This 1 becomes a 0, then you'll have to add the 5 to the 0. Well, that makes this a 5. So 5 minus 4 gives me 1. 5 minus 4 gives me a 1. I need to borrow again. I cannot take away 1 from a 0. So let's borrow from the 4. That gives this a 3, or makes it a 3, and the 0 becomes a 5. And so 5 minus 1 gives me 4, and we bring down the 3. So this is it. Our solution is 3, 4, 1, 4, base 5. So please pause the video and try these questions on your own. So let's do it together now. We have 1, 2, 2, 1, base 3. And I'm going to subtract 1, 2, 2, base 3. Do it. 2 cannot be subtracted from 1. We'll have to borrow. This becomes a 1. I need to add an additional 3 to this 1, so that becomes a 4. Remember, we're borrowing a 3 since this is base 3. Now I can subtract 4 minus 2 gives me a 2. We'll have to borrow again. This reduces to a 1. I'll add an additional 3 here, and this becomes a 4. 4 minus 2 is 2. 1 minus 1 is 0, and this becomes a 1. So now we have our solution, 1, 0, 2, 2, base 3. For part B, we have 2, 3, 1, 2, base 4. And we're going to subtract 2, 0, 3, base 4. I cannot take away 3 from 2. We'll borrow from the 1. That makes that a 0. This becomes a 2 plus 4. Since we're talking about base 4, this is actually a 6 now. 6 minus 3 is 3. 0 minus 0 is 0. 3 minus 2 is 1. Bring down the 2. So our solution is 2103, base 4. For part C, we're talking base 2, so let's stack it up again. I cannot subtract 1 from 0. We borrow from the 1, that becomes a 0. We'll have to add that 2 back to the 0. That makes it a 2. Remember, we're borrowing a 2 since this is base 2. And so 2 minus 1 gives me 1. 0 minus 0 is 0. Cannot take away a 1 from a 0, so we'll have to borrow. This becomes a 0. And we're adding a 2 to this because this is base 2. 2 minus 1 gives me 1. So our solution is 101 base 2. Part D, this is base 10. You know base 10, so let's do this one very quickly. 1 minus 1 is 0. I cannot subtract 1 from a 0, so we'll have to borrow. We're borrowing not a 1, but we're borrowing a 10. This is base 10. 10 minus 1 gives us 9. So this is our solution, 90. In question number 9, please practice this on your own. Get good at this because you'll see this on your exam. So let's make sure you're good at this. For the first one, we're talking base 6. For the second one is base 3. And for the third one is base 8. So let's do the work. 5 minus 3, that's 2. I cannot take away the 3 from the 1, so let's borrow from the 2. That makes this a 1. And then we'll have to add 6 back to the 1, which is 7. 7 minus 3 is 4. I cannot take away 3 from the 1. We'll borrow from the 3. That gives us a 2 here. And we'll have to add a 6 back here. That makes that a 7. 7 minus 3 is 4. And then we'll bring down the 2. Our answer is 2, 4, 4, 2, base 6. For B, I have 1 subtracted from 2 is just a 1. 2 subtracted by 2 is 0. 1 subtracted by 1 is 0. So this is 2, 0, 0, 1, base 3. Part C is base 8. 2 minus 0 is 2. I cannot take away a 2 from a 1. So I'll have to borrow. But the 0 does not have anything. So we'll have to borrow from the 3. And that reduces that to a 2. But I'm going to have to add 8 back to the 0. So that makes that an 8. Then I can borrow from the 8. We'll make that a 7. But then we're forced to add the 8 back to the 1, which makes that a 9. 9 minus 2 is 7. 7 minus 5 is 2. Then we'll have to borrow from the 7. That makes that a 6. But we're going to add the 8 back to that 2. So this actually becomes a 10. 10 minus 4 is 6. Then we'll bring that 6 down. So that's our solution, 6, 6, 2, 7, 2, base 8. So please practice these problems. Get good at adding and subtracting different bases.